Here are co-authors of the paper Young People's Burden, which we will talk about today. I also want to point out the co-authors of the complementary paper published earlier, Assessing Dangerous Climate Change, which included, in addition, experts in economics, human health, coral reefs, and plant and animal extinctions.
Global temperature is one of the metrics that helps us assess climate change. Earth's temperature fluctuates naturally because the atmosphere and the ocean are fluids that slosh about, and because some forces that drive climate change, such as the sun's brightness, are variable. But if we average global temperature over 11 years, as shown by the red curve, we see that global temperature has been rising steeply over the past 50 years, while greenhouse gases such as CO2 and methane have been increasing rapidly. The 11-year average largely removes the effect of solar variability as well as the effect of El Niños and La Niñas, which are natural warming and cooling cycles of the surface water in the tropical Pacific Ocean. Global warming since pre-industrial time now exceeds 1 degree Celsius, almost 2 degrees Fahrenheit. Over land, the warming is almost 3 degrees Fahrenheit. And there is more warming in the pipeline, as confirmed by the Earth's energy imbalance. The energy Earth absorbs from the sun now exceeds the heat energy Earth emits into space, so warming will continue. This imbalance is caused by greenhouse gases, which absorb heat radiation, reducing the energy emitted into space. If we want to stop further global warming, we must reduce the amount of these gases in the air to restore planetary energy balance. CO2 would need to be reduced from its current amount, about 405 parts per million, to about 350 ppm or less.
Our best tool to judge the long-term effect of global warming is to look at how Earth responded to warming in the past. The rapid warming in the last century has raised global temperature well above the range that has existed in the current interglacial period, the Holocene, which covers the past 11,000 years. It takes time for Earth to respond to higher temperature, but ice is beginning to melt all over the planet. We show in our new paper that global temperature, now more than 1 degree Celsius above pre-industrial, has already reached the level of the prior interglacial period, the Eemian, 120,000 years ago, when global sea level reached 6 to 9 meters. That's 20 to 30 feet higher than today. If global temperature stabilized at today's level, we could expect to eventually get such large sea level rise, but it may take many centuries to reach that level. However, in the paper, Ice Melt, Sea Level Rise in Superstorms, we concluded that if rapid fossil fuel emissions continue this century, the time scale for multi-meter sea level rise is likely to be only 50 to 150 years.
The delayed response of ice sheets and sea level is an example of the intergenerational nature of human-caused climate change. Small sea level rise is just beginning to touch cities such as Miami, so it does not provide much incentive for today's adults to reduce emissions. However, the science is understood well enough. If high emissions continue, sea level will rise by meters. Global economic effects of losing coastal cities would be disastrous, and there is the potential for hundreds of millions of refugees. This intergenerational injustice violates the rights of young people and future generations to life, liberty, and the pursuit of happiness and property, without due process of law. The courts must step in to help us. There are many other effects of climate change. If high emissions continue, climate zones will continue to shift more rapidly than has ever occurred in Earth's history. Together with other human-caused stresses, this may cause 1/4 to half of the species on Earth to be committed to extinction by the end of this century. Effects are beginning already. For example, coral reefs, the rainforests of the ocean, are harboring more than 1 million species, are beginning to suffer losses. Sea level rise, species extinctions, and increase of extreme climate events are all well-established effects of the increased atmospheric CO2. These effects are global. They provide a basis for legal action against all governments, many of which seem to be working more for the fossil fuel industry rather than for the public.
Our paper's title, Young People's Burden, derives from the fact that continued delay by governments in adopting policies that rapidly reduce emissions, such as a carbon fee, will leave young people with the task of somehow extracting CO2 from the air if they are to stabilize climate and avoid disastrous climate effects. If fossil fuel emission reduction had begun in 2013, the time of our PLOS One paper, the CO2 drawdown could have been achieved by reforestation and improved agricultural and forestry practices. Now, continued high emissions have left young people a situation in which technological extraction of CO2 from the air is needed. The burden placed on young people may become too heavy to bear if governments do not begin rapid emission reductions soon. But instead of looking at projections for this century, let's look at what is happening right now, because there is a false narrative that we have turned the corner toward a solution.
Let's look at how the greenhouse gas climate forcing of the Earth is changing. A climate forcing is a perturbation of Earth's energy balance. For example, if the sun becomes brighter, that is a positive forcing that causes warming. The variation of the sun's brightness over the 11-year solar cycle is about 1/4 of a watt per square meter, a small cyclic forcing. Greenhouse gases keep changing in the same direction, increasing, so they have become a powerful forcing causing warming. The net forcing caused by the change of atmospheric composition over the past 200 years is a forcing greater than 2 watts per meter squared, which has caused global warming of more than 1 degree Celsius, with several tenths of a degree warming in the pipeline if the atmospheric composition stays the same as today. However, the gases keep increasing, so the forcing keeps increasing. In recent years, the greenhouse gas climate forcing has been increasing by about 0.04 watts per square meter each year. That doesn't sound like much, but it's 4 watts in 100 years, which would cause an eventual additional warming of 3 degrees Celsius based on the climate sensitivity from paleoclimate data as well as climate models. Such warming, the scientific community agrees, would be a disaster. It would become difficult to live in the tropics and subtropics. Shorelines worldwide would be a continual retreat inland. So the IPCC, the Intergovernmental Panel on Climate Change, has defined a scenario for emissions reduction to be called RCP 2.6, which is nearly equivalent to 3% reduction per year. If this scenario were achieved, it would limit global warming to about 1.5 degrees Celsius above pre-industrial. We recommend a somewhat steeper reduction, which would get global temperature back close to the Holocene level by the end of the century. However, it is sufficient to compare the real-world changes with RCP 2.6 to reveal the situation. The rate of growth of climate forcing is not decreasing, it's increasing. To get back on the RCP 2.6 plan to limit warming to 1.5 degrees Celsius, we must extract some of the increased gas from the air. Let's look at the gap in a single year, 2015. Climate forcing growth in 2015 in the RCP 2.6 plan was 0.0352 watts per meter squared. But the actual growth was 0.0485 watts per meter squared. So the gap was 0.0133 watts per meter squared. This excess growth should be extracted from the air if young people are only going to obtain a planet no more than 1.5 degrees Celsius warmer than pre-industrial. Most of the excess growth is in CO2, and most of the extraction must be of CO2. Let's say we extract enough CO2 to reduce the forcing by 0.01 watts per meter squared. That would require a reduction of atmospheric CO2 by 0.7 ppm. 1 ppm of CO2 is 2.12 billion tons of carbon, so 0.7 ppm is about 1.5 billion tons of carbon. Cost estimates for extracting CO2 from the air, as discussed in the paper, range from $150 to $350 per ton of carbon. So the cost to extract the 1.5 billion tons of carbon is between $225 billion and $525 billion. That is the cost to remove the excess CO2 emissions in a single year, 2015.